What's up, guys? It's Rustin. I'm just here giving an update on my indoor 360 photogrammetry processing side of a digital twin project I'm working on. So before I show you the actual model, I just want to show a little bit of like the code. Um, Basically, what we're doing at first is we're walking around, with the camera. It's a 360 video. I'm just gonna show you an example what it would look like, as an equirectangular format. So you're just kind of walking around with this thing, right? This is the low angle. I did a low, medium, and high pass, and you'll see why here just in a little bit. But you're walking around and capturing all this data. Um, Obviously, this is pretty good. This was shot in 8K at 30 FPS. But for photogrammetry, at least in the software that I use, which is Reality Scan slash Reality Capture, it doesn't process this natively. So there's a workaround that I had to do. So let me go back here. First of all, we're going to download this software called FFmpeg. It is completely free and it is amazing. If you guys have ever used this, please use this. And basically, we're gonna, through the software, we're gonna actually create some folders. This is really just directory stuff. Before I even I'm making a directory before I even actually use FFmpeg. So when you're opening up your terminal or kernel and you're typing this stuff in there, whatever. This is just making me some directories. Um, and so from there, what we're doing is actually extracting all the frames out. So let me go back to the low one real quick. Um, and I'll explain it. So these were all the frames from the low video, right? These are all the frames, but however, they are staggered. I know that they're high quality. I did this in PNG lossless, or at least I tried my best to do it so that I would keep as much data as possible. Um, but using this was pretty nice. However, we didn't need every single frame, so you can kind of see how I have it staggered. And the way I did that is by almost pulling out around 2 FPS. Honestly, I might experiment with just doing 1 FPS if I just put like toe to toe while I walk, so I walk even slower. But this would help me get a better discrepancy between each of the frames. But for now, we're just trying out 2. You can see I used a PNG with 0 compression. So these are these are pretty big file sizes. And you can see here's all the frames from the low. And then again, I did the same for the middle and high shots are the same exact thing. These are just the video files. So from there, I actually generated a cube map. Now that is what this segment of code is right here. All this is using is FFmpeg to create all these different cube maps here. I'm honestly thinking about going to a rectilinear approach, but we're soon to just kind of figure that out. This is what worked for me. It's worked reasonably well. I do need to improve this though, and probably improve some stuff in photogrammetry as well, just because it's not perfect. But again, this was just a test run to proof concept. Um, so yeah, here you guys go. So like a first frame, right here's the cube map it generates. So you can I'll just do this quickly. You can see as I walk down the hallway, it's making the cube map, right, which is exactly what we want. And so it's just doing that for all the different angles you could possibly have. But again, rectilinear might be the way to go. Moving on here. But let me show you actually what's really cool. So from there, we're going to go into reality capture. Again, here's an actual model. Let me let me turn on this so you can actually see what I'm talking about. This is the low res, so choose if the farts. So this is the untextured super high res. You can see this has nearly 46 million triangles. Again, it's not a perfect model by any means. It was just simply a test, but you can see all our different capture points, right? So up top here, I mean, it's kind of diverging just because I didn't hold the tripod too still. That's my fault. Um, but all this stuff here, right? This is the high, middle pass. There's the low pass that I was showing you, and it put it all together. So I'll show you a more compressed, textured version. This is my 12th attempt at the model. These numbers are a little bit inaccurate. Just we're looking at this one right here. Okay. So this is a textured version of it on the inside, and again, the floor isn't perfect. It was at an oblique angle, whole 9 yards, at least the processing side. It's not perfect. It's simply a test, but you can kind of see it sort of did piece it all together. I kind of have an idea with how we can improve this. Maybe like a multiple camera setup because I'm just walking individually with one camera at a time. I gotta try my best to keep it as steady as possible. Maybe like some sort of gimbal that can hold, camera here, camera here, camera down here as I walk would be perfect, right? That would be awesome. Also improving sort of what it's pulling from for a larger discrepancy. Again, we're having these sort of ghosting texture artifacts as well here. This is not ideal, but it's not hateful. I'm trying to make sure that when we get a model, it's actually nice and cleaned up. But this is just it's a proof of concept. Kind of it works. right? We can see it, it didn't. And it's all from a 360 camera. So it's kind of sick. Um, so yeah, again, this is a compressed model. It's went from 45 to 1 million triangles, so a lot of stuff going on there. And again, it has a texture file. This is a more compressed version of it and more simple version. Again, texture is a little bit more rough, it's more smooth. But again, yeah, this is just a different version of the model. Yeah, you can see, look at that. That's pretty good. It's pretty good resolution there on that on the planning board and the geography board. You kind of almost read it. But yeah, it's pretty cool what you can kind of do with the camera. I'm hoping to present this sort of research. It's kind of sick. It's so awesome. Um, but yeah, all I'm using is Reality Scan, Reality Scan 2. You gotta do this is free. Literally, this is free, so you can just use this. Maybe a little bit of Blender for like cleaning things up after this model has been made before I import it into Pro. Um, this has nothing to do with the outside of the building, which is like outdoor photogrammetry. I have done stuff like that. I wonder if I have that one on. Oh, give me 2 seconds and I can show you what I'm talking about for an outdoor model. Um, I think it would be. Um, I'm sorry that this is taking forever. This is kind of off script with the video. I don't really mind, but I was just trying to see where I stashed it. I was just flying around with the. Did I do that? Oh, I had one that was like it was kind of cool. Um, maybe in here. No, it was in my drones data and code presentation, but you can see the outside of Henson. Um, I'll literally pull this up real quick because I have a picture on standby. Yeah, it's my background on LinkedIn, but you can see like this was when we flew the outside of the building. What we're actually doing, like this whole thing that's on the inside of the building, here, um, is actually just a segment of the geography wing. So when this loads, right, this whole segment. Let's see. Let me orient myself. There's the lizard. Okay, so that means that the exit's this way. Okay, so from this orientation, again, doesn't have the outside of the building, so there's no textures. This is actually this portion of the first floor down here, which is kind of sick. So we have the first floor partially mapped, that whole first floor segment. But again, this is Henson from the outside, and this was just shot from top down. I would have to get these more oblique look around and get a complete model, but you can kind of see it. Maybe in my next video, I'll show you a more concise version of this. Wait, I can I can pause it. Let me pause it and let me actually find the actual. Uh, so the reality model I have is a little bit broken right now. So we're just opening it up in Pro instead. This is actually just simply a point cloud that has been turned into an elevation model using the reference layer. So again, this is Henson Hall. So you can see this is all using photogrammetry. We can actually compare this. It's what's funny. Thank you, Dr. Harris, for this. But this is an actual LiDAR model. And again, these are on two different scale systems. They're not uniform. They're two different objects. You can see that. But this is what it actually looks like with LiDAR. Uh, oh, this is what it looks like with LiDAR. This is what it looks like with the photogrammetry. Again, that's why the color coding is different, the scaling systems. But again, you can see we got a pretty good capture of the building roughly. That's pretty awesome. Look at the detail we even have the triangle area. That's pretty awesome, right? So we can see we can get the outside capture. The outside capture is pretty simple to do. I just have to kind of move around and get these more under surface areas. Let's, you know what I'm saying? Like fly the drone, maybe like at this oblique angle and this pattern, and then have it face the building rather than being like a straight 90-degree angle for complete coverage. But we can see it looks pretty good. If I toggle on the tip, it's just all it's doing is being blanketed over. Obviously, you're not going to be able to see the size of the building because it doesn't have that data. But we can see if we put ourselves as like a 90, like an ortho almost. It looks pretty good. It looks pretty darn accurate for what we got, right? So, pretty awesome. There's Sammy Sequel down there. Wonder what he looks like from the side. He's not modeled. It's funny. But anyway, so there's a proof of concept. Again, it works. At least the outside portion. We showed the inside portion as well. So just a little progress update. Today is March 1st, 2026, 2 p.m. It's a nice little Sunday. Just thought I would record this as a little update. So yeah, thanks for watching. I don't know who's watching this. Um, yeah, I'm learning this too. This is a cool project, and I really hope they get it working. And I really hope to present something at CIRSIC. So I will, oh, I will be excited to do that. All right. Everybody take care. Yeah. Bye bye.